Question 1. In a college, 25% of boys and 10% of girls offer mathematics. The girl constitute 60% of total number of students. If a student is selected at random and is found to be studying mathematics, the probability that the student is. We have four options: A 1 by 6, B 3 by 8, C 5 by 8, and D 5 by 6. Let 100 students studying in which 60% girls and 40% boys, that is boys is equal to 40% and girls is equal to 60%, where 25% of boys offer maths. So for 25% of boys offer maths, that is equal to 25 by 100 into 40, we get as 10 boys, and 10% of girls offer maths, that is equal to 10 upon 100 into 60, which we get as 6 girls. It means 16 students offer maths, that is 10 plus 6, 16. So required probability is equal to 6 by 16, that is 3 by 8, which is option B. Option B is the correct answer. Question 2. If f of x is equal to 3 into 1 minus 2x square for x greater than 0, less than 1, or if f of x is equal to 0 otherwise, is a probability density function of x, then probability of x greater than 1 by 4, less than 1 by 3 is, we have four options: A 179 by 864, B 179 by 468, C 719 by 846, D 846 by 790. We have probability which is x greater than 1 by 4, less than 1 by 3, equal to, we have limits 1 by 4 to 1 by 3, f of x dx. We substitute the function. We integrate, we get x minus 2x cube upon 3, 1 by 4 to 1 by 3. We substitute the value of limits in x. We get 3, 1 by 3 minus 2 by 81, minus of 1 by 4, 96. We solve this, we get 179 by 864, which is option A. Option A is the correct answer. Question 3. If A and B are any two events, then the probability that exactly one of them occur is, we have four options. For the required probability, A occurs and B does not occur, or B occurs and A does not occur. So we can say that the required probability is equal to A occurs and B does not, or B occurs and A does not. So we can write it as P A of intersection of P bar plus P A bar intersection of B. We can write this as P of A minus of P A intersection of B plus of P of B minus of P A intersection of B, which is equal to, you can write P A plus P B minus of 2 P of A intersection B, which is our option B. Option B is the correct answer. Question 4. Let A and B be the two events such that probability of A union B bar is equal to 1 by 6. Probability of A intersection B is equal to 1 by 4. and probability of A bar is equal to 1 by 4, where A bar stands for complement of event A. The events A and B are, we have four options, that is A independent but not equally likely, B mutually exclusive and independent, C equally likely and mutually exclusive, D equally likely but not independent. We have probability of A union B bar is equal to 1 by 6. Probability of A intersection B is equal to 1 by 4. Probability of A bar is equal to 1 by 4. So that is probability A is equal to 3 by 4. So we can write probability of A union B bar as 1 minus A union of B. Therefore we can write A union B as P of A minus of P of B plus of probability of A intersection B. We substitute the values, we get 1 by 6, 1 by 4 minus of probability of B plus of 1 by 4, where we get as probability of B is equal to 1 by 3. Since P probability, that is A intersection of B, equal to probability of A into probability of B, and probability of A is not equal to probability of B, since we can see that B is equal to probability of A into probability of B, and probability of A is not equal to probability of B. So therefore A and B are independent but not equally likely. Therefore option A is the correct answer. Question 5. If an integer is chosen at random from first 100 positive integers, then the probability that the chosen number is a multiple of 4 or 6 is, we have four options, that is A 41 by 100, B 33 by 100, C 1 by 10, and D none of this. Let A be the event to be multiple of 4 and B be the event to be multiple of 6. So probability of A is equal to 25 by 100, probability of B is equal to 16 by 100, and probability of A intersection of B is equal to 8 by 100. So the required probability is probability of A union of B is equal to P of A plus P of B minus of P of A intersection B. We substitute the value, we get as 25 by 100 plus of 16 by 100 minus of 8 by 100, that is equal to 33 by 100. We solve this, we get 33 by 100. Therefore option B is the correct answer. Question 6. A random variable x has the probability distribution. We have table given as x 1 2 3 4 5 6 7 8, and for every x we have probabilities. For the event E, x is a prime number, and for f, x is less than 4. The probability of E union F is, we have four options, that is A is 0.50, B 0.77, C 0.35, and D 0.87. So we solve for E, that is x is a prime number, so for probability of P we get P2 plus of P3 plus of P5 plus of P7, which is equal to, when we solve this we get as 0.62, and for F we know that x is less than 4. So probability of f is equal to p1 plus of p2 plus of p3. We solve this, we get as 0.50. So the union, that is probability of E union of f, that is p of 2, sorry, E intersection of f, p of 2, p of 3 is equal to 0.35. We solve for union, that is the formula we have for union, p of E plus of p of f minus of p of E intersection of f, which is equal to 0.62 plus 0.50 minus 0.35 is equal to 0.77, which is our option B. Option B is the correct answer. Question 7. If A and B are even such that P A union B is equal to 3 by 4, P of A intersection B is equal to 1 by 4, P of A bar is equal to 2 by 3, then P A bar intersection of B is, we have 4 options. We have P of A union B equal to 3 by 4, P of A intersection B equal to 1 by 4, P of A bar is equal to 2 by 3, which is P of A is equal to 1 by 3. We have formula, that is P of A intersection B equal to P of A plus P of B minus P of A union B. We substitute the value, that is 1 by 4, 1 by 3 plus P of B minus 3 by 4. We solve this, we get P of B is equal to 2 by 3. So we substituting in the formula of A bar intersection of B is equal to PB minus of PA intersection of B. Substituting the values, we get 2 by 3 minus 1 by 4, which is equal to 8 minus 3, 12, which is equal to 5 by 12, which is our option A. Therefore option A is the correct answer. Question 8. If A and B are independent events of random experiments such that probability of A intersection B is equal to 1 by 6 and probability of A bar intersection of B bar is equal to 1 by 3, then PA is equal to, here E is a complement of the event E. So we have 4 options, A 1 by 4, B 1 by 3, C 1 by 2 and D 2 by 3. So given that P probability A intersection of B is equal to 1 by 6 and probability of A bar intersection of B bar is equal to 1 by 3. Since A and B are independent, therefore P of A and P of B is equal to 1 by 6 and P of A bar, P of B bar is equal to 1 by 3. So 1 minus of P of A, 1 minus of P of B is equal to 1 by 3. We solve this, we get as PA plus of P probability of B plus of probability of A into probability of P equal to 1 by 3. We substitute the values, we get 1 plus 1 by 6 minus 1 by 3 is equal to P of probability of A plus probability of B. We solve this, we get as probability of A plus of probability of B is equal to 5 by 6. Further solve this, we get P of A is equal to 1 by 2, P of B is equal to 1 by 3, and we get P of A is equal to 1 by 3, probability of B is equal to 1 by 2, which is, we see that we have 2 options, that is B and C, 1 by 3 and 1 by 2, 1 by 2 and 1 by 3. So B and C both are the correct answer. Question 9. For the 2 events A and B, if probability of A is equal to probability of A upon B is equal to 1 by 4 and probability of B upon A is equal to 1 by 2. Then we have four options, that is A and B are independent. B, probability of A complement upon B is equal to 3 by 4. C, probability of B complement upon A complement is equal to 1 by 2. So D, all of this. We have probability of B upon A is equal to 1 by 2, which we can write it as probability of B intersection of A, probability of A, which is equal to 1 by 2, which we get this as probability of B intersection of A is equal to 1 by 8. We also know that probability of A upon B is 1 by 8, which is equal to probability of A into probability of B. So even A and B are independent. We can say that events A and B are independent. So option A is the answer. We further solve it. Now probability of A complement of B, which we can write as probability of A complement intersection of B upon probability of B, which is equal to probability of A complement probability of B upon probability of B, which is equal to 3 by 4. And we can write this as probability of B complement probability of A complement is equal to this. We substitute the values, we get 1 by 2. So we can say that A complement of B we get as 3 by 4, that is correct. For B complement of A complement we get 1 by 2, that is even correct. Even we see that even A and B are independent, so option D is the correct answer, that is all of this. Question 10. A man is known to speak the truth 3 out of 4 times. He throws a die and reports that it is a 6. The probability that is actually a 6 is, we have 4 options, A 3 by 8, B 1 by 5, C 3 by 4 and D none of this. Let E denote the event that a 6 occurs and A be the event that the man reports that it is 6. So we have P of E is equal to 1 by 6. P of complement, that is probability of E complement, will be 5 by 6. So we have probability A by E, which can be written as 3 by 4, and probability of A upon E complement 1 by 4. From Bayes' theorem, we have probability of E upon A is equal to probability of E, probability of A upon E, probability of E, probability of A upon E, plus of probability of E complement, probability of A upon E. We substitute these values, we get 1 by 6, 3 by 4, 1 by 6 into 3 by 4 plus 5 by 6 into 1 by 4. We solve this, we get as 3 by 8, which is our option A. So option A is the correct answer. Question 11. Bag A contains 4 green and 3 red balls, and B contains 4 red balls and B green balls. One bag is taken at random and a ball is drawn and noted it is a green. The probability that it comes bag B, that is A 2 by 7, B 2 by 3 and C 3 by 7 and D 1 by 3. This question, if you see, is based on Bayes' theorem. So probability, we use a Bayes' theorem formula. So probability of picked bag A, that is P of A is equal to 1 by 2 probability of A picked bag B, that is probability of B is equal to 1 by 2. So probability of green balls picked from bag A can be written as P of A into P G upon A equal to 1 by 2, 4 by 7, substituting the values, so we get 2 by 7. So probability of green ball picked from bag B can be written as, this is bag B, this is bag A, can be written as probability of B, probability of G upon B equal to 1 by 2 into 3 by 7, which is equal to 3 upon 14. So total probability of green ball is equal to 2 by 7 plus 3 by 14, which is equal to 1 by 2. Probability of fact that the green ball is drawn from bag B, we use Bayes' theorem, that is G upon B equal to probability of B, probability of G upon B upon probability of A, probability of G upon A plus of probability of B, probability of G upon B, which is equal to 1 by 2, 3 by 7, 1 by 2 into 4 by 7 plus 1 by 2 into 3 by 7 is equal to 3 by 7. We solve this, we get 3 by 7. Therefore, option C is a correct answer. Question 12. In a binomial distribution, the probability of getting a success is 1 by 4 and the standard deviation is 3. Then its mean is A6, B8, C12 and D10. Probability of success, that is P, is equal to 1 by 4, and probability of unsuccess, that is Q, is equal to 3 by 4. Mean is given as N into P, so the standard deviation is equal to under root of variance, that is variance is equal to 9. So NPQ is equal to 9. We substitute the values we get. So therefore N is equal to 48. So for the mean, N into P can be written as 1 by 4 into 48 is equal to 12, which is our option C. Option C is the correct answer. Question 13. The two cards are drawn successfully with replacement from a well shuffled deck of 52 cards. Then the mean of the number of is. We have four options: A 1 by 3, B 3 by 13, C 2 by 13 and D none of this. Let X denote a random variable which is the number of aces. X takes the value 1, 2. Therefore we get P is equal to 4 by 52, which is equal to 1 by 13. Q is equal to 1 minus of P, that is 1 minus of 13, equal to 12 by 13. For probability, that is X is equal to 1, we get as 2 into 1, 13 into 2 upon 13 equal to 24 upon 169. Probability for X is equal to 2. 2 into 1 by 13 the whole square. 12 by 13 raised to 0. 1 upon 169. For mean, we have summation of Pi xi. So we add both the probabilities. 24 by 169 plus 2 by 169, which is equal to 2 by 13. Therefore, if we see option C is the correct answer. Question 14, for any two events A and B in a sample space, we have four options. We're gonna solve for every options. If we see, we take A, that is for probability A upon B greater than equal to P of A plus P of B minus of 1 upon P of B, comma, where P of B is not equal to 0 is always true. So we solve for A, that is, we know that probability of A upon B is equal to A of probability of A intersection of B upon probability of B. Also we know that probability of A union B is less than equal to 1. So probability of A plus probability of B minus of probability of A intersection B less than equal to 1. We solve this, we get probability of A intersection B greater than equal to probability of A plus probability of B minus 1. We solve this further, we get A intersection B probability of B greater than equal to probability of A plus of probability of B upon probability of B minus 1. So we can say that A is true for any two events A and B in a sample space. So therefore, if we see, we get the condition for B also, where probability of B is not equal to 0, where probability of B is in the denominator. So therefore A is the answer. Question 15, if A and B are two events such that probability of A union B is equal to probability of A intersection B, then the true relation is, we have four options. A, probability of A plus probability of B is equal to 0. B, probability of A plus probability of B is equal to probability of A into probability of B upon A. C, probability of A plus probability of B is equal to 2 into P of A, P of B upon A. D, none of this. We have A union of B, probability of A union of B, which is equal to probability of A plus probability of B minus probability of A intersection B. We also have probability of A intersection B is equal to probability of A plus probability of B minus of probability of A intersection B. Since we have probability of A union B is equal to probability of A intersection B, we substitute the value of A union B as A intersection B. We solve this, we get as probability, that is 2, probability of A intersection B equal to probability of A plus probability of B. So 2 into probability of A into probability of A intersection B upon probability of A is equal to probability of A plus probability of B. We solve this further, we get as 2 probability of A into probability of B upon A, which is equal to probability of A plus probability of B, which is our option C. Option C is the correct answer. Question 16, two dice are rolled one after the other. The probability that the number of the first is smaller than the number of the second is, we have four options: A 1 by 2, B 7 by 18, C 3 by 4 and D 5 by 12. Consider two events, that is A, getting a number I on the first die, that is getting a number I on first die and B, I getting a number more than I on second, more than I on second I. So the required probability, that is P of A1 intersection of P B1 plus probability of A2 intersection of probability 2 plus probability of A3 intersection of probability 3 plus probability of A4 intersection of B4 plus probability of A5 intersection of B5. So we get as summation of I equal to 1 to 5 probability of AI intersection of BI, which is equal to summation of I equal to 1 to 5 probability of AI probability of BI, where AI and BI are independent, so we get 1 by 6 probability of B1 plus probability of B2 plus of probability of B5. We substitute the value, we get 1 by 6, 5 by 6 plus 4 by 6, 3 by 6 plus 2 by 6 plus 1 by 6, which is equal to, we solve this, we get a 5 by 12, which is our option D. Option D is the correct answer. Question 17. A and B toss a fair coin each simultaneously 50 times. The probability that both of them will not get tail at the same toss is, we have four options: A 3 by raised to 50, B 2 by 7 raised to 50, C 1 by 8 raised to 50, and D 7 by 8 raised to 50. For each toss there are four choices, that is, first one, A gets head and B gets head. For second, A gets tail and B gets head. Third, A gets head, B gets tail. Fourth, A gets tail, B gets tail. So the exhaustive number of ways of the ways of this all four choices can be written as 4 raised to 50. Out of the four choices listed below, above, that is 4, is not favorable to the required event in a loss. So therefore the favorable number of cases is 3 raised to 50. The fourth one is not favorable, so the required probability can be written as 3 by 4 raised to 50, which is option A. Option A is the correct answer. Question 18. If probability of B is equal to 3 by 4, probability of A intersection B intersection of C bar is equal to 1 by 3, and probability of A bar intersection of B intersection of C bar is equal to 1 by 3, then the probability of B intersection C is, we have four options: A 1 by 12, B 1 by 6, 6 1 by 15, and D 1 by 9. From Venn diagrams we can see that if we draw a Venn diagram for A and B and C, which all three are intersecting to each other, this is C, this is A, and this is B. For this circle we can write A bar intersection of B intersection of C bar, and for this we can write as A intersection B intersection of C bar. So for probability of B intersection of C can be written as probability of B minus of probability of A intersection B intersection of C bar minus of probability of A bar intersection of B intersection of C bar, which is equal to, we substitute the value, we get 3 by 4 minus 1 by 3 minus 1 by 3. We solve this, we get as 1 by 12, which is our option A. Option A is the correct answer. Question 19. A man and his wife appear for an interview for 2 posts. The probability of the husband selection is 1 by 7 and that of wife selection is 1 by 5. What is the probability that only one of them will be selected? A 1 by 7, B 2 by 7, C 3 by 7 and D none of this. The probability of husband is not selected is given as 1 minus 1 by 7 is equal to 4 by 5. The probability that only husband has been selected is equal to 1 minus 1 by 5 is equal to 4 by 5. The probability that only wife is selected is equal to 1 by 5 into 6 by 7, that is 6 by 35. So the nth required probability can be given as adding all the probability, that is equal to 6 by 35 plus of 4 by 35 is equal to 10 by 35, which is equal to 2 by 7, which is our option B. Option B is the correct answer. Please note that we also find the probability of wife is not selected, which we get as 1 minus 1 by 5 is equal to 4 by 5. So we solve accordingly. We get required probability, that is 6 by 35 plus 4 by 35 equal to 10 by 35 is equal to 2 by 7. So therefore option B is the correct answer. Question 20. A draws 2 cards with replacement for a pack of 52 cards and B throws a pair of dice. What is the chance that A gets both cards of same suit and B gets total of 6? We have 4 options: A 1 by 144, B 1 by 4, C 5 by 144 and D 7 by 144. So the probability of drawing 2 cards of same suit, that is, we can write it as 3 by 52, that is 13 by 52 into 13 by 52, and it can be only suit out of 4. So probability of A is equal to 4 into 13 upon 52 into 52. Please note that this is 13 by 52, which is equal to 1 by 4, and probability of B is equal to 5 by 36. Thus probability of A intersection B can be written as probability of A into probability of B, which is equal to 1 by 4 into 5 by 36, which is equal to 5 by 144, which is our option C. Option C is the correct answer. Question 21. The probability that in a year of 22nd century chosen at random there will be 53 Sundays is, we have options: A 3 by 28, B 20 by 2 by 28, C 7 by 28 and D 5 by 28. So we know a leap year is fallen within 4 years, so its probability of a leap year is 25 by 100, that is equal to 1 by 4. 53rd Sunday in a leap year is equal to 1 by 4 into 2 by 7, which is equal to 2 by 28. So similarly, probability of 53rd Sunday in a non-leap year, right here, non-leap year, that is 53rd Sunday, we get as 75 by 100 into 1 by 7 is equal to 3 by 4 into 1 by 7, that is equal to 3 by 28. So the required probability equal to 2 by 28 plus of 3 by 28, which is equal to 5 by 28, which is option D. So option D is a correct answer. Question 22. A bag contains 3 red and 7 black balls. 2 balls are taken out at random without replacement. If the first ball taken out is red, then what is the probability that the second taken out ball is also red? We have 4 options: A 1 by 10, B 1 by 15, C 3 by 10, and D 2 by 21. We have total number of balls, that is 10. Total balls equal to 10. Number of red balls equal to 3, and number of black balls equal to 7. Number of balls in the bag, that is 3 plus 7 is equal to 10. So the probability for taking out one red ball out of 10 balls taking out one red ball out of 10 is 3 by 10. So the probability of taking out one red ball out of remaining 9 balls, taking out one red ball out of remaining 9 balls is equal to 2 by 9. So probability of both balls to be red is equal to P is equal to 3 upon 10 into 2 upon 9, which is equal to, we solve this, we get 1 by 15, which is our option B. Option B is the correct answer. Question 23. An unbiased coin is tossed. If the result is head, a pair of unbiased dice is rolled and the number obtained by adding the number on 2 faces is noted. With the result in a tail, a card from a well shuffled pack of 11 cards number 2, 3, 4, 12 is picked and the number on the card is noted. The probability that the noted number is either 7 or 8 is, we have 4 options, that is the values of probability 7 and 8. We have A 0.24, B 0.244, C 0.024, and D none of this. So the required probability, we can say that the required probability is equal to probability that either the number is 7 or the number is 8. Either the number is 7 or number 8. So the probability, required probability, can be written as P7 plus of P8. So now for P7, we have 1 by 2 into 111 plus 1 by 2 into 6 by 36. We solve the probability part and we add it, we get 1 by 2, 111. This goes, we get left with 1 by 6. We solve this, we get as 0.244. Sorry, we get this as We further solve for probability 8, that is 1 by 2 into 1 by 11 plus 1 by 2 into 5 by 36. We solve this, we get as 1 by 2, 1 by 11 plus 5 by 36. So the probability, that is adding P7 and P8, substituting the value of P7 and P8, we get as 1 by 2, 2 by 11 plus of 11 by 36. We further solve this, we get as 0.244, which is our option B. Option B is a correct answer. Question 24. Odds 8 to 5 against a person who is 40 years old living till he is 70, and 4 to 3 against another person now 50 till he will be living 80. The probability that one of them will be alive next 30 years. We have 4 options. We find probability a person A will die in 30 years. That is P of person will die. Person A will die in 30 years. That is equal to 8 upon 8 plus 5, which is equal to 8 upon 13. So probability of A bar, that is complete, we get 5 by 13. Similarly, for B, we get as 4 by 7. Probability of B bar is equal to 3 by 7. There are 2 ways in which one person is alive about 30 years. That is A into B, that is A bar into B, and A into B bar, and event are independent of each other. So the required probability can be taken as P of A bar into P of B plus P of A into P of B bar, which is equal to 5 by 13 into 4 by 7 plus 8 by 13 into 3 by 7, which is equal to 44 by 91, which is our option B. Option B is the correct answer. Question 25. 2 persons A and B take turns in throwing a pair of dice. The first person to throw off 9 from both dice will be awarded the prize. If A throws first, then the probability that B wins the game is A 9 by 17, B 8 by 17, C 8 by 9, and D 1 by 9. So the probability of throwing 9 with 2 dice is equal to with 2 dice is equal to 4 by 36 equal to 1 by 9. So the probability of not throwing nine with 2 dice is equal to 8 by 9. So if A is to win, he should throw 9 in first or third or fifth attempt. That is first or third or fifth attempt. If B is to win, this is for A is to win, and for B to win, he should throw 9 in second, fourth attempt. So the chances of B can be 8 by 9 into 1 by 9 plus of 8 by 9 raised to 3 into 1 by 9 plus equal to 8 by 9 into 1 by 9, 1 minus of 8 by 9 the whole square, which is equal to 8 by 17. Therefore, option B is the correct answer. Question 26. One bag contains 5 white and 4 black balls. Another bag contains 7 white and 9 black balls. A ball is transferred from the first bag to the second, and then a ball is drawn from second. The probability that the ball is white is, we have 4 options: A 8 by 17, B 40 by 153, C 5 by 9, D 4 by 9. Let white ball be transferred from the first bag to the second. The probability of selecting white ball from the first bag that is P is equal to 5 by 9. Now the second bag has 8 white and 9 black. The probability of selecting white ball from the second bag is equal to 8 by 17. So hence the required probability can be the multiplication of both. Therefore, the required probability is equal to 5 by 9 into 8 by 70, which is equal to 40 by 153. If a black ball be transferred from the first bag to the second, then the probability can be written as 4 by 19 into 7 by 17, which is equal to 28 by 153. So the required probability as addition of both the probability, that is 40 by 153 plus of 28 153 equal to 4 by 9, which is option D. Option D is the correct answer. Question 27. For any two events A and B in a sample space, we have given 4 options, that is A, B, C and D. So we're going to solve for all the options. So we're going to start with A, that is for probability of A upon B is equal to, we can write this as probability of A intersection B upon probability of B. So further we solve, that is probability of A plus probability of B minus of probability A union B upon probability of B, which is less than equal to probability of A plus probability of B minus 1 upon probability of B. If we see option, that is probability of A upon B greater than equal to probability A plus probability B minus 1 upon probability B, we get option A as answer. We further solve, we see that probability B is not equal to 0, which is true for A. Therefore, the choice B holds only for disjoint, that is probability of A intersection B, which is equal to 0. And over here also we can say that probability of A union B is less than equal to 1. So finally we can say that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B equal to probability of A plus probability of B minus probability of A into probability of B. So therefore A and B are independent, so we can write 1 minus of 1 probability of A, 1 minus of probability of B. If we further solve this, we get 1 minus of probability of A into probability of B. So if we check this, we get option C also. Therefore option C is a correct, but option D is not correct as it holds for disjoint, that is probability of A union B is equal to probability of A plus of probability of B, which is So we get two answers, that is A and C. So therefore option A and C are both the correct answer. Question 28, let x and y be two events such that p x of y is equal to half, p y by x is equal to 1 by 3, and p x intersect of y is equal to 1 by 6. Which of the following are correct? We have four options. P x union of y is equal to 2 by 3, p x and y are independent, c x and y are not independent, and d p of x complement intersection of y is equal to p y minus p x intersection of y. So we have p x by y is equal to half probability of x intersection of y upon probability of y, which is equal to half. So we get p of y is equal to 1 by 3. Further we have p of probability of y by x is equal to 1 by 3. We solve this, we get as probability of x intersection y upon probability of x is equal to 1 by 3. That is probability of x is equal to 1 by 2. So probability of x union of y is equal to probability of x plus of probability of y minus probability of x intersection y, which is equal to 2 by 3, where we can say A is the correct answer. For p probability x intersection of y is equal to probability of x into probability of x and y are independent, we can say B is the correct answer. So for complement we see, therefore option C is being neglected. We can say therefore x and y are independent, so not independent option, that is C, can be neglected. So for x complement of intersection y is equal to p of y minus of p x intersection y. So we can solve this, we get 1 by 3, 1 by 6. We solve this, we get 1 by 6. Therefore D is not correct. Therefore our option that matches, that is A and B. Therefore A and B are both the correct answers. In 29, if the probability density function of a random variable x is fx is equal to x by 2, in x greater than equal to 0 less than equal to 2, then the probability of x which is greater than 1.5 of x is greater than 1 is equal to, we have four options. We solve for fx is equal to x by 2, that is for probability x greater than 1 by 5 equal to, we have limits 1 by 5 to 2, so x by 2 dx. We integrate this, we substitute the value of limits in x, we get 0.4375. For probability of x greater than 1, that is 1 to 2, x by 2 dx. We integrate this, substitute the value of limit in x, we get 0.75. Hence for probability x greater than 1.5 upon x greater than 1 is equal to probability of x greater than 1.5 upon probability of x greater than 1. We substitute the value, that is 0.4375 upon 0.75, which is equal to 7 by 12, which is our option C. So option C is a correct answer. In the D, if A and B are two events such that probability of A is half, probability of B is 2 by 3, then we have four options. So we have probability of A union of B, which is greater than equal to maximum of probability of A comma probability of B, which is equal to 2 by 3, and for probability of A intersection of B less than equal to minimum probability of A comma probability of B, which is equal to 1 by 2. So, and for probability of A intersection B equal to probability of A plus probability of B minus of probability of A union of B greater than equal to probability of A minus probability of B, which is equal to, that is minus 1, which is equal to 1 by 6. So we can write this as 1 by 6 less than equal to probability of A intersection B less than equal to half. So for probability A complement intersection of B is equal to probability of B minus of probability of A intersection B. Hence 2 by 3 minus of 1 by 2 less than equal to probability of A intersection A complement that is A complement intersection of B less than equal to 2 by 3 1 by 6. If we check, we solve this, we get 1 by 6 less than equal to probability of A complement intersection of B less than equal to 1 by 2. We get all the values for every probability, therefore D is the correct answer. That is, all of this are the correct answers.